All right, cool. So it should be recording. My Zoom controls look different right now, so it's throwing me off a little bit. And now I need to upgrade tonight, so I'm sure they're going to look even different tomorrow. Okay, so getting started. Today we're going to talk about objects, classes, and instances. So we've got a bunch of learning goals. I'm really ambitious that we're going to get through all of these. And the idea is that, that you're not an expert at this stuff by the end of this session, but that you have a better understanding of how these work, and then you know how to focus your time and energy on what to be studying. So we're going to talk about defining a class. What is a class? What is an instance? And what's the difference between the two? We are going to talk about instance variables defined in an initialize method, which I'm sure you may have seen if you've done Ruby exercises. We're going to talk about providing access to state or attributes using things called attr readers and attr accessors. We're going to talk about methods to provide behaviors for instances of a class. And we're going to create new instances of a class and call methods on that instance, okay? And if none of that makes any sense, that's okay. That's why you're here, so we can learn about these things. So for the warm-up, if you've got like a notebook or a text editor you're keeping notes in, you're going to want to have that handy. But what I'd like you to do is brainstorm, don't start yet, let me explain it first. Brainstorm a type of object and specific instances of that object. For example, if my type of object is a water bottle, maybe specific instances. Let's see, today I've got this like colorful one with my Apple logo on it. And I've also got this pink Starbucks one. I always have like 3 or 4 water bottles at a time. So those are my specific instances of water bottles. And then brainstorm 3 different attributes for those objects. So these ones might be the brand, the color, has a straw, and then potential behaviors. So I could fill my bottle, empty my bottle, close the lid. Okay, so think of any object, just look around your room or your space and find an object and brainstorm the type, what specifics look like, specific instances, attributes, and behaviors. So it'll take about 3 minutes for you to go ahead and brainstorm that. Oops, I never started that time. Resuming recording. So I'd love for a couple of you to share out the object that you created, what specific types are, and the attributes and behaviors. Ben, if you're willing to come off mute, if you want to help out a little bit and share what you brainstormed.
Yeah, so I went with like a phone class, and so I had 3 attributes. One was a resolution, which was a float variable, and then I had 2 strings with name and brand, and then another float with volume. And then my methods were mostly focused on those volumes and the resolution. And so I had a volume up method, which increased the volume by 1. And then I had a mute method, which set the volume to 0. And then I had like a screenshot function, which would it would allow you to edit the resolution and like kind of crop the screenshot that you took.
Awesome. And what would be some specific instances of this phone object?
So the instance that I had would be Ben's phone. And so, I would just set the resolution to like 1080 big phone. And then, the name, Ben's Pixel or whatever. And then the volume start at 100, something like that. I don't know, just kind of placeholder variables.
Sure. So you're saying like, yeah, you can definitely create those, but like just generalized, this is perfect, right? So you have an object of a phone, and then specific instances of this phone would be Ben's phone, my phone, Meg's phone. And then we have specific attributes that describe the state of this phone. So what is the resolution? What is the name of this phone? And then behaviors or actions that those phones would take. Awesome. Thanks so much for sharing, Ben. Cool. Any questions about this like brainstorming example? Maybe that's a vague question right now. Yeah, Vanessa.
I think I get a little bit confused about how specific you have to be about the instance, because it says that it has to be unique. So like Ben's phone is very unique, but what if it was like iPhone 6 black? Would that be enough?
Yeah, that's a really good question. And that's something that you have to decide, right? So would iPhone, whatever, 10 in black, would that be considered an instance of a phone class? I think it very well could be. There's an argument to say yes, but maybe you've got another object that's specifically iPhones, right? And then you have instances of specific iPhones, right? So maybe there would be like the 10 and the 11 and whatever other, the SE, like, right, the specific models of an iPhone. So I think it just depends on how you structure the architecture of your object. I'm going to say it in kind of vague terms right now until we jump into this a little bit more.
Okay, in this case, in your example, object is still like instance from the class or no?
No, the object is kind of like the generalized thing.
It is not in any way under a class.
Well, so what we're going to see, this object is the class. So this is going to be the class, right? So if we had a class of phone, what would those specific phone instances look like?
Okay,
right?
Thank you.
Yeah, great question. And I love that you helped me tie it together there. And that's what part of what you're going to be doing. And what part of the hard part of programming is making these kinds of decisions is, what is my class going to be? And so let's go ahead with this water bottle class that I had in the beginning, and we'll talk about syntax while we kind of talk about what's going on here. So if we have this class of water bottle, syntactically, let's do a little playground. Oh, actually, that's not a good idea. Let's do this. The class should always be stored in a file that matches the class's name. Okay, so I'm going to make a new file called waterbottle.rb, and my water bottle is 2 words, so I'm putting a underscore between it in the file. Okay, so I've got now a water bottle class, and how I actually write the class, the syntax, is I use a keyword of class. I write the name of the class in what's called upper camel case. So like every word, it's all together, but each beginning of the word is capitalized. And then we have an end. That is the syntax to create a class. If it was a single word like phone, it would just be like this, like capitalized phone. Okay, but we're doing water bottle. Okay. So now what is this class? So we can think of the class as like a blueprint for any kind of water bottle instances we're going to create. This class is going to help define the specifics about this, like the state or these attributes that we established here. So every water bottle is going to have a brand, and so our class will help us determine, or will help store and keep track of what is the brand of a specific water bottle instance. So what is an instance, right? An instance is a specific representation of this class. So I have like this purple water bottle, and this would be one instance because it's a very specific representation. It has very specific state, as in a specific color. It's got a straw. I just got water all over myself. Good thing I was away from my computer. But that's a specific instance or specific representation of this class. And the class just kind of acts as a blueprint. We'll come back to this metaphor. I think sometimes once we get into it, it's a little easier to see why this definition works and how it works. All right. So actually what I'm going to have you do is I'm going to get you like jumping into the code right away. Okay. And this is I'm going to task you with some things that you might not be able to know you might not know how to do yet. And that's okay. You're going to be in groups of 4, and there is a lesson plan link that you can refer to. There is Google. There's a lot of things that you can reference to try to figure this out, the tasks. And I'm going to put them in your Slack channel. So give me just a second here. We're going to spend about 10 to 12 minutes in our breakout rooms doing these 5 tasks and just get as far as you can. I'm going to be popping in and out of each of the breakout rooms to see what questions you have, and then we're going to come back together to discuss what questions came up, what you figured out. One person in your group is going to be the screen share person or the driver, and it's going to be the person whose birthday is coming up next. Okay, so no one has to think about it. That's what the determining factor is, okay? All right, let me get these breakout rooms set up here. One second. Okay, perfect. Any questions about what you're doing? Someone said, do you have a question? Okay, let's just pop in and see what we can do. All right. Breakout rooms should be open. All right, cool. Looks like everyone's back in. So let's go ahead and review the task. I jumped through all the rooms and it seems like you all were moving along just fine. So that's awesome. So I'm going to call on one of you to kind of help walk me through how you did some of these tasks. The file's already created, so we can skip down to class to number 2. Max, do you want to come off mute and help me do number 2, which is create our class of dog and discuss 3 attributes. And we can go ahead and write those attributes.
Sure thing. So you want to start by lowercase class and then uppercase dog.
Awesome.
And always good to put end at the end. Yeah.
I agree.
And the 3 attributes that we did were a dog breed, weight, and if the dog is a good dog. So good dog.
Your dog doesn't have a name? Can I just give the dog a name? Seems like a vital piece of information.
Sure.
Is good. That is a good one also. All right, cool. So those are the attributes. And so Max, how did you all get those attributes? Actually, before we continue there, Sam, do you have a question?
In the Slack message, I think you wanted us to test it using like require by the pry session.
Mm-hmm.
Anytime I try to put pry at the end of any file, it doesn't run. And I saw a lot of people had similar situations. And I'm just using the default terminal. I'm not sure if you could come over that with the iTerm to like other people use, but I can never have pry running as the last line. It always skips that.
Right. So the pry, like, does it error or just doesn't do anything?
It doesn't do anything. If I put some fluff code at the bottom, it will run as long as it's not the last line.
So pry is kind of like an invisible line of code. So sometimes you have to add like a 0 or something below it so that your program will actually hit the pry. Because sometimes, and it's funny, I don't know why, like, because it doesn't do it with mine, but it definitely does it with other people's code. So it could be like a version thing of my Atom where it just, because pry is kind of invisible, it just won't see it. And so you have to add that code below it just so that it can hit the pry. So that's a normal behavior. Cool. And actually, let's do that now, actually. So we, Max, I will come back to you, so give me 1 second. But let's go ahead and on number 2, I had mentioned doing a requiring in the file. So whenever you want to refer to the class, right? So in this runner file, we're going to make some dog instances. And so if we want to pull and look at this blueprint of the dog class, we need to actually pull that information into this file. Now, when you learn testing, you're going to be doing a lot of this via testing, but we don't have that implemented just yet. So I'm just going to use a runner file to help me do this. And so I can actually, even though we've only talked about the attributes, I can still create an instance of dog right now. Catherine, do you want to help me like create a couple dog instances right here?
Sure. So we have dog 1, right?
Mm-hmm.
And then that would be equals dog capital D dot new. Is that right?
Yeah, that is right.
That's what we did. Okay, and then we have to put in our attributes after that.
Well, let's
So-
stop right here for a second.
Oh, okay.
Yeah, but and why did you do this? Like, what is this?
That's just the variable we're assigning the dog to.
Yeah, and why do we need to do that? Any ideas?
I was just thinking otherwise it wouldn't be assigned to anything. It wouldn't go anywhere.
Yeah, so it would still do it, right? If we did dog.new right here, and we ran this file, it would create this dog instance, but it wouldn't store it anywhere, so we'd have no way to access that information. So this is perfect. Let's do a dog2 also, and then let's stick our pry down here. Thank you so much, Catherine.
Mhm.
And then I'm going to go ahead and run this file. Cool, I hit my require. So again, mine does this, I don't know why, but some people's you have to add a 0 just so your program knows that the file's not ending on line 6. So cool, so in our pry, it's like the program is paused, and so I can see here that these 2 lines of code ran. So if I take a look at my dog1, that's what it holds, and this is what dog2 looks like. So what you're looking at here is an object. So this is how the terminal is going to display the object to you. It has this like pound sign and the caret, and then it tells you what class this object is like implemented from. I want to say like cookie cuttered from, because to me a class is kind of like a cookie cutter, and now I'm making specific dog instances. What do you think this refers to? This like long string of characters. Ben?
I think 0x is a hex value and it's referring to a memory address.
Yeah, so it's showing us where this dog instance is stored in memory. And so we can see, thank you so much, Ben, we could see that these 2 numbers are different. So we have 2 different instances of our dog. And now these dogs are kind of boring right now. We haven't assigned any attributes, right? But actually, let's do the thing that Catherine was talking about, adding in the actual. Can you all still hear me? Okay, my computer like shifted its sound. So, okay. So let's say we have breed, name. Actually, I'm gonna, just for the sake of brevity, get rid of that one. So we have name, weight, and breed. And so how would we pass that information into the .new? How about Jesus? So I've got the attributes of name, breed, and weight. How would I pass that information into
So in the after .new, you add a parentheses, which is the arguments. So we're gonna put name Sparky.
Sparky, I like it.
And then for the breed, Labrador. And then for the weight, I don't know, 15. I don't know how much a
15,
Labrador
like a little
weighs.
puppy.
Oh, I don't know how much.
I think labs are more like 60
Oh, wow.
pounds. So
Oh, wow.
I've been researching dogs, so I know this a little bit. All right.
Okay.
Yeah, perfect. And then we can do that same thing with this. So we're passing this information in as arguments. And some of you might be thinking I've missed a couple steps, and you're right. So, but give me 1 second. I want to look at this. So how about a Fido? Can be a Husky, and those are like a little bit more, like 78 pounds, right? So if I run my program now, Adam, I see you, I'll get to you. If I run this file right now, hold please. Okay, so if I run my runner.rb right now, I'm gonna get an error. Can you guess in your head what that error might be? Just think to yourself what the error might be. Okay, let's run it and see. So this practice of like making an assumption and then running the code to test your assumption will be a great way to see if you are following and you know exactly what your code is doing. All right, so our error is that we've got the wrong number of arguments in initialize. Expected 0, given 3. What is this telling me? Anyone know? Vanessa?
It's telling you that when you create it, like in the initial, well, you don't even have an initialize right now. So you need that. And then once you do that, it's saying that you need to expect 3 arguments if you want to create it with 3 arguments.
Yes, exactly. So with Ruby, what happens is whenever .new is called, it creates this dog object for us. And then it automatically calls the .initialize method. And that's where the initialize is what's going to collect those arguments that we pass in. So we don't even have that right now. And so Max, this is where I'd like you to continue helping me, is how can I structure my initialize method to accept these arguments?
Sure. So once you've defined initialize, you want to also pass in, so open parens, and then you can do breed, or we have first name, then breed, then weight, or I think that, yes, that's right.
Yes.
And then within the initialize, you want to do at name equals name, at breed equals breed, and at weight equals weight.
Cool. Can you talk me through what is going on here? And then we will take a palm.
Sure. So you are setting the attributes of dog to be equal to what you've passed in. So when you instance that dog with Sparky, you're now assigning Sparky's name to be Sparky.
Yeah, and perfect, Max, thank you so much. So the order we pass these in does matter. It's expecting whatever the first argument that comes in here is the name. Whatever's the second argument will represent the breed, and the third argument will represent the weight. Okay, and then we're going to store them in what's called an instance variable. Okay, when it has this little @ sign in front of the variable name, it's called an instance variable. Anyone know the difference? We'll talk about this more tomorrow, but does anyone know the difference between a regular variable like this and this instance variable? Joseph.
An instance variable you can use wherever it is attached to that, where a regular variable you can't bring into other methods necessarily. It can't be changed with other methods.
Yeah, so what you said there is key, that this variable, so if I did it like this variable cannot be accessed from other methods. An instance variable, and what's called this, it's scoped to the class. We'll talk about scope tomorrow, but it means I can access this instance variable at name from any method within this class. So that gives me a little bit of flexibility there. Now, I don't have to call this name. This could be called like banana, and then that could be banana. And, you know, that makes absolutely no sense in this context. But what I'm trying to illustrate is, like, a lot of times we make all these names and variable names match, but they don't have to. So if I pass in something called banana, I could say, all right, whatever banana is, store that as the name attribute of this dog. Okay, and we can see that in action real quick. Okay, so I ran this, I hit my pry again. Now if I look at dog 1, this is really low, isn't it? Now I can see I do have that same dog attribute, that dog object, but now the dog has some attributes. It has a breed, has a name, and it's got a weight. Vanessa, question?
Yeah, do you mind showing what would happen if we did not put the instant variables there and just did the initialize?
Like just did this?
Yeah.
Yeah. So we can run that. Oh gosh, So now if we look at dog 1, it's just an object. It doesn't have any instance variables, because those instance variables are going to be attached to the specific instance.
Got it. Thanks.
Cool. Yeah, great question. All right, let's go ahead and take a 5-minute palm, and then we'll come back and pick up. Is back on. Great. So where were we at? Let's get banana back to something that makes sense. That is helpful. The name of your variables matters. We want it to make sense. Any questions come up over the palm about anything we've done so far? Robert?
I think one thing I might just point out is initialize being what it is. A lot of, especially early problems for me previously was in initialize is how you spell it. And sometimes you can get maddening errors trying to figure out where everything looks right and you're missing an I in it. So just something to point out.
Yeah, that's so frustrating because I spelled it wrong right now. I'm glad you pointed that out because that will drive every one of you crazy at least once in your Ruby career. But if you look here, the error that it's telling me, it's not that, hey, you spelled initialize wrong. What it's saying is, hey, wrong number of arguments. So what it's saying is like initialize, it doesn't see this initialize. So it's saying, okay, initialize then needs 0 arguments and you're giving it 3. So if you get this error and you're like, no, there's 3, I'm passing in 3 arguments. I see 3 arguments right here. Maybe my program, maybe Ruby's broken. It's surely not me. No, the problem is then look to make sure that you spelled initialize correctly. I spell it wrong all the time. So initialize. I like that, Robert. Thank you. All right, cool. And so with these dog instances we have now, we've got our attributes here, but it's going to be important that we're able to access those attributes. So I know this is dog 1, but if I want dog 1 to tell me his name, it'd be nice if I had a method that would give me that information. So when we, our method syntax is we have an object, we use our dot syntax and then call the name of a method. So what I would really like to have happen is that we have a method called name that would spit back to me the attribute of this specific dog's name. Right now, that method does not exist. So I know that some of you did, well, a lot of different things. How about Karen? Do you want to share how your group created that method?
The method for the name?
Yes.
So you would want to, underneath the class dog, do an adder reader, colon name.
Yes.
And that should create the method.
This is true. Now this is a shortcut. Thank you so much, Karen. So this is a shortcut. Oh, come on, Ruby, or autocorrect rather. This is a shortcut. What is this actually doing? What is the adder reader doing? Anyone know? Karen, go ahead.
So the adder reader is like a method, right?
Mm-hmm.
So it acts as a method that like just accesses other methods. Is that right?
Kind of. It's a method that would access the attribute, right? So if I wanted to write this out, I would actually create a method called name, and then the only job of this method would be to read back this instance variable. So remember we said that instance variables can be accessed from any method within the class. So the job of this method now becomes to just read back the value of this attribute. And will this work? Well, oops, let's exit. Let's rerun our program. And now we can see that indeed we have a method called called name that does give us back the value of that @name attribute. Okay, Ben, go ahead.
Yeah, I was just kind of wondering when you would want to use self in this whole thing. And when
None, not at all.
Okay.
Yeah, you're not going to need to use self, and we'll have a whole nother discussion on self in a couple weeks, but you're not going to need to use that for really anything that you're doing in your first couple projects.
Okay.
Cool. Vanessa, question?
Yeah, 2 questions actually. So as I understand, you're showing 2 different ways to create the method. One you put in the reader, and the other one you're creating in a normal way.
Mm-hmm.
So the first question is, we would never need both, right? If
Correct.
Okay. And the second question is, when is necessary for me to put it in the reader?
I would say always. So what I'm doing here, because this is so common in Ruby, right? That we just need these methods to read back our attributes. And so doing this like a million times is going to get really redundant and lead to some lengthy code that's really not necessary. So Ruby gives us this really nice shortcut of the attr reader to replace all those methods so that we don't have to write them out longhand like this, right? So you're right, Vanessa. If I had this, let me just undo, I would now actually have two methods called name, right? That can cause some confusion for Ruby. So we never want to have both of them here. So our attr reader does for us is what I had listed longhand. It creates those methods for us, and it's a shortcut. But whenever you use a shortcut, I want you to be very clear about what is happening. Okay, Adam, question?
Yeah, our group, I think just because we'd seen it more recently, we did use the attr accessor. I don't want to get ahead of this lesson if we want to focus on reader, but just want to make sure I understand. Does attr accessor do everything reader does and then some, or is it a little bit different?
So here's the deal with attr accessor is I would say try not to use attr accessor unless you absolutely have to, because what attr accessor does is creates what's called a setter method so that these attributes can be changed from outside the class. Okay, so what I could do, like if I have this as an attr accessor, what attr accessor does is combines attr writer and an attr reader. So if I had another method called attr writer of name, then what I could do is if I went over here, I could say like dog1.name is Sparky, but now I want to change his name. So I can now, oh gosh, change it to Bob, and now his name is Bob, right? Maybe you want that, but maybe you don't want to give that power outside of the program. Maybe you want the class itself to handle something like that. So if you had a method called like change name and takes in a new name, then what you'd want is your method to access the instance variable directly to actually change the name. Right? So then this attribute's technically only being accessed from within the class. So it's about limiting power or not power, but like accessibility to the outside of this class. We want to limit that. So always start with an attr reader, and then in your methods, it's good practice just to access the attributes or the instance variables themselves. That way now, over here, if I was in this program now, if I tried to change the name by like just setting the name, it's going to say, no, you can't do that. So then I'd have to actually use this method, and then the class would be responsible for changing the name. So very slight difference, but it's all about the responsibility of this class, not the responsibility of a runner file to change the name of our dog. Great question. Cool. So probably for most of the stuff you're going to do in mod 1, you can get away with only having attr readers. There's going to be some cases you might want an attr accessor once you have multiple classes interacting, but maybe not. Cool, great question. Okay, where are we at? All right, we've got all of our attributes. We have methods. What is one of the other behaviors that you added? Alex, what did your group add another behavior that you want to share with us?
We just did a speak method that produced like a, ARF kind of thing.
How would you make it say like ARF, maybe your dog speaks English too, and so it could say ARF, my name is whatever my name is. How do we do that?
So you could use like, you could use def speak and then you could just go ahead and type that out as a string, ARF, and then use string interpolation to put the @name in there.
Okay, so like my name is, and then we can do some string interpolation @name, right? And so that should, whichever instance I call this on, it should access its own name attribute and actually speak to us. So let's try it, make sure it works. So dog1 first I'm just going to say, check his name is Sparky. So I expect that he was going to say, Arf, my name is Sparky. Great. And dog 2, speak. Awesome. Great job. I love it. Okay. Now, Vanessa, go ahead.
Sorry, I was bothered by the fact that I'm talking too much.
Oh, you're fine.
I forgot. Sorry, I got flustered.
Okay, if you remember, just raise your hand again. Okay. Perfect. And then, and I'm sure this is apparent now. I just want to remind you that I'm not looking at the chat. So if you have any questions that the group would benefit from, I highly recommend either asking them verbally or putting them in the thread in the code help channel, right? Because as soon as we end this session, the chat is gone. And so no one has reference to that information anymore. Jordan?
Yeah, I was just wondering real quick, why we use symbols for the attribute reader.
Yeah, it just has to do with, so symbols are like, we'll talk about symbols later, but it's a data type and it stores a lot of things. And one of the things in Ruby it can store is like a method shortcut, or it can store a reference to a method. And that's kind of what it's doing here.
Thank you.
Yeah, great question. Yeah, this little, this colon in front of the variable name, this is called a symbol in Ruby, just so everyone knows. And we'll talk more about symbols in another lesson. But let's say our dog has some toys, right? Dogs have toys. And how would we store those toys? Now that's something we're gonna wanna keep track of, right? Because maybe the dog gets a new toy, and then a new toy, and then a new toy. So the dog has 3 toys, right? And that's like a collection of toys. And so those are the dog's toys, and then he destroys one, so we need to throw it away. So now that collection, he just has 2 toys. So that's something we wanna keep track of for this specific instance, because Sparky and Fido are gonna have different toy collections. So what data type do you know of that would store a collection? Just yell it out, go ahead. Anyone?
An array.
Array. Woohoo, good job. A lot of people said that, an array, right? So what we can do is in our initialize, we can set up a collection to be started whenever a dog is initialized, right? So I didn't pass this information in, but what I'm saying is every time a dog is initialized, go ahead and just create this container where we can start storing the dog's toys, okay? So now let's look here. If we look at dog 1, we can see that @toys is now a attribute, right? Have I given myself access to see those toys yet? Negative. So we want to make sure we add that here. This is getting very long horizontally, so you can stack them vertically. That is fine syntactically. Coders don't like to read horizontally. We like to read vertically. So, so now if we do dog1.toys, I can see we have an empty array. Joseph, question.
I was wondering why the values don't always return in order.
Yeah. Yeah. So they here in the terminal, they're going to just list themselves in alphabetical order. It doesn't.
Oh.
Yeah. It doesn't make a difference to anything that you're going to do.
Okay. Cool.
Yeah. Here, you'll just want to list them in a way that contextually makes sense. Okay. Y'all ready for some breakout rooms? I almost just wanted to say, you're all ready for this? Dun, dun, dun. Anyone know that song? Please tell me I'm not the only one.
No, not the other one.
All right, so we're gonna do breakout rooms again to kind of pick up where this left off. So you all have your dog class. We're gonna be in, let's do different breakout rooms so you can meet some more of your cohort mates. But we'll do some different breakout rooms. Again, I want to stress when you're in these breakout rooms, whoever the driver is just the one kind of typing, so you all have a point of reference of the code you're working on, but it is a collaborative process, right? So the driver is not responsible also for coming up with all the ideas. That should be a conversation, and your driver is just there to document and record that. So the person who's going to be the screen share or the driver this time is the person whose name is first alphabetically, like your first name, will be the group share, the screen share. And there's the tasks. No. Sorry, that is not the tasks. Delete. I apologize. Give me 1 second here. Oh, that's why. Hold on. We're not doing breakout rooms yet. What I want you to do, just keeping you on your toes, friends. What I want you to do is think about this and maybe write this down in a notebook or in a text editor that you're keeping notes in. But I have this toy collection. I need a behavior now or an action that will allow me to add a toy to this collection. So take a couple minutes to see if you can create or think about how you would write that. Okay, let's see about 3 minutes for you to think about that.
Somehow I don't think I got tossed into a breakout room.
Yeah, you're not in breakout rooms right now. So you're just working independently to see if you can figure out what the action would look like in order to add a toy into a dog's toy collection. So either just writing that out in a journal or writing it in a text editor. All right. Eli, would you be willing to? Okay. So recapping, we might also want to store, say, a collection of items for a specific instance. So maybe this dog has toys and we want to keep track of all the toys that this dog has and gets and receipts. So what we can do is create an instance variable and set it equal to an array, which can hold our collection of items. So now we're going to need an action or a method to actually add toys to this array. So the pattern we typically follow is name the method exactly what we want the action to be. We're going to pass it an argument. Here, maybe I'll call it new toy. And then this is an array. And remember, because it's an instance variable, I can access it from within any method in the class. And then I can shovel in the new toy. So now here, when these strings come in and are passed to this method, they will add those to this toys collection.